basically, we're going to pretend like this is a right triangle right here, and draw it in. So that's a right triangle. And remember this, the first three right here, that's the x, so that's this distance right there, how far it goes to the left or right. And then the other three is the y value, so that's how far it goes up, that's 3 here. So now we've basically just got a right triangle where we're missing the hypotenuse over there. So I'm going to do a squared plus b squared equals c squared. And that makes 3 squared plus 3 squared. 9 plus 9. 18. Take a square root on both sides because it's positive. So now the c is the square root of 18. Okay. Now, so if this side is the square root of 18, now we have to do right? We have to do opposite and hypotenuse. So, the opposite side is the opposite of this angle right here that they mentioned. So that's 3 on top, and on the bottom is the square root of 18. Okay. So the square root of 18, first of all, can be broken down a little bit like this. It can be the perfect square 9 times 2, so 9 times 2 is 18, that makes 3 square roots of 2. So I'm actually going to break it down over here to 3 over 3 square roots of 2, which leaves us with them canceling out. You end up with 1 over the square root of 2. And another stupid math rule that every mathematician has kind of decided to follow, kind of almost like grammar, with English, is that you never have a square root on the bottom in your answer, which is funny because a few of the ones earlier actually did have square roots on the bottom in their answer, like this one. Yeah, so, but it's not supposed to be allowed, which is why none of these do. So this is called rationalizing the denominator. It's a stupid trick where you multiply by the square root of the thing that's down here on the top and the bottom, because technically this means I'm multiplying by 1, you see? Because the same thing's on the top and the bottom. So if I multiply across, the top is the square root of 2. The bottom is the square root of 2 times the square root of 2, which is the square root of 4, which makes it the square root of 2 over 2, which is C. These are tough problems, guys. And if you haven't taken advanced math or pre-calculus, you should not be beating yourself up over these. This is very difficult. So you'll learn more about this in advanced math. Okay. So it says that cosine and tangent multiplied each other equals sine. And sine is the square root of 7 over 4. So what is cosine? Okay. Well, I don't really think we need that formula to help us out. We can just do the trick that we've been doing and it will work. So let's do it that way. Alright, so we've got a right triangle and I get to pick an angle this time. So I'm going to pick, I don't know, this one. And let's see, sine is opposite over hypotenuse, right? So this one's opposite, this one's hypotenuse. So opposite is over here, the square root of 7. Hypotenuse is up here, that's 4. I don't know what this is. So I'm going to take b squared plus the square root of 7 squared equals 4 squared. The square root of 7 squared cancels each other out, so you end up with just 7 equals 16 minus 7 on both sides. B squared equals 9. Then take the square root, square root. B is 3, so this side right here is 3. Okay, what is cosine? So cosine would be ca, adjacent over hypotenuse, so that's 3 over 4, 3/4. Next up, if it's between 0 and 90 degrees, remember that all that means is that cosine and sine are going to be positive. So then right here we've got this equation. We have to solve for theta. So this is one where you're really going to need a calculator. Okay, so first thing I'm going to do is add 3 on both sides. Treat cosine just like it's a variable. You want to get it by itself first before you can even dig into the inside. Then you divide by 4 on both sides. That's cosine squared theta equals 3/4. Okay, and then to get rid of the square, we're going to take a square root on both sides. So that is cosine theta equals the square root of 3 over 2. Now, if you're in advanced math and you've got your unit circle memorized, because you're amazing like that, then you can do that. But if you don't have that memorized, which most of us don't, you can go here and do an inverse cosine. So see how there's a cosine button right above this parenthesis. But instead, if I hit like a inverse cosine instead, what are the chances somebody would call me right when I pull up my phone? If I do the inverse cosine instead and just type in exactly that, so that'd be the second square root of 3 divided by 2, and then another parentheses, and I put that in, I get 30 degrees. Now, to make this work, it is important that your calculator, that the mode is set to degrees, not radians. Radians is another way to measure angles, which we'll find out later in this same thing. So 30 degrees. Okay. Remember, if I'm going too fast, pause anytime you like, or zip forward if you understood a question, or if you were stuck in another one, pause. Great. Whenever sine over tangent is defined, it is equivalent to which of the following? Okay. So, let's see, what's an easy way I can put this? Yeah, we'll do it this way. Okay, so we know SOHCAHTOA. So you could say that sine is like opposite over hypotenuse, right? And then we're going to divide that by tangent, which is opposite, over adjacent. If you're dividing fractions, you flip the second fraction, so that's actually like opposite over hypotenuse times adjacent over opposite. And do you see how the opposites cancel each other out then? So you end up with adjacent over hypotenuse, which is cosine right there. So cosine is the adjacent over hypotenuse, so that's just F. Number 9, a large sail is being sewn for a racing yacht. You know, I'm sure we all have that experience, having a racing yacht. I know I do. It's one of my many yachts. This is the one for racing. Which of the following expressions could be used to calculate height of the sail? All right. So I'm going to write down, let's see, I've got, this is the angle I care about. This is the adjacent angle right here. It's annoying that it's called H because it's not the hypotenuse, but this side is the adjacent side to 20 degrees. I'm going to write a big A right there. And this side over here is the opposite, and then I have no idea what this side is. So since I have an O and an A, that's what I'm trying to figure out right there, I'm going to use TOA, T-O-A, because I've got the opposite and the adjacent side that I care about. So if I say the tangent of 20, that's the angle we care about, is equal to opposite. Now the whole thing is 16, so each side is 8, divided by, they're calling it H there, right? And then I have to get H by itself to solve for that. So I'm going to cross multiply, make that real easy. 1 times 8 is 8. This is H times the tangent of 20. And then to get H by itself, I'm going to divide by the tangent of 20 on both sides. So I end up with H equals 8 divided by the tangent of 20, which is E. Okay. All right, now this one, the resource I was using actually had a misprint in it, so I had to fix this here. So from the top, this is like a really deceiving picture, because if you look at this, this angle is supposed to be 5.074 degrees, when actually like 5 degrees, so like if this is 90 degrees, 5 degrees is like really, probably even tinier than that, more like that, okay? So you can kind of imagine that this peak of this mountain, and then they're looking like 30 degrees up, like really, really, really far away, is Everest. So instead of it going up dramatically like this, imagine that these mountains are very far apart. And we're trying to figure out what this height is, and actually what the height of all of Mount Everest is. And we know that so far, that this much is 15,000 feet. So remember, this part may be far more than that is, just because this picture is so bad. Okay, now we also know that since this is a vertical height, that is a right angle right there. And we are trying to find out what h is. So compared to this angle, I have h is, again, of course, not actually h, it's the opposite over here. And this is the hypotenuse up here. So I want to use the part of SOHCAHTOA that has an opposite and hypotenuse, which is sine, opposite over hypotenuse. So I'm going to write down that the sine of, let's see, 5.074 is equal to the opposite, which I guess we don't know, h, divided by 158,400 feet. Okay, now to get